Okay, so we were actually in this chemical reaction, we were actually able to figure out that where the oxidation is happening and where the reduction is happening. But you must know that oxidation is a loss of electron, and I've just told you that when we are splitting the redox reaction into oxidation and reduction reaction, means two different reactions. We have for oxidation, we have to show the electrons on the product side. For the reduction, we have to show the electrons on the reactant side because it's going to be the gain of electron there, right? So let's see how many electrons have been lost in this chemical reaction here, which is what we call the oxidation reaction. So we had iodine, and iodine here was just one iodine with a negative sign. And when it goes into this form here, right? So no, I know that the oxidation state on iodine is +5. So I'm going to just write it small +5 here. And I have to write the complete compound. I cannot just write the ion there. Okay, so it's a molecular ion IO3 minus. So guys, now it's going to be the loss of electrons. So I have to show the number of electrons on the product side, which is total electrons being lost is 6 electrons. So I have to show it like that. 6 electrons are being lost. And in this one, what's going on is we had the chlorine, and the chlorine is going to go into Cl minus, right? Cl minus. It means this is a diatomic chlorine having a 0 on it. I have to balance these atoms on both sides too, right? Don't forget that I'm not going to, and because its reduction is the gain, I have to show the electrons on the reactant side. So it's going to be 2 chloride ions coming out of this diatomic chlorine. So how many electrons are being gained here? It's going to be 2 electrons. So reduction is a gain of electron, oxidation is a loss of electron. We just try to clean it a little bit and do not show the charges after that. Oh, we have to show the charge to the electron anyways, right? Like this. Then, because it's an ion, so I have to show it for this one here. I'm going to show the ion, not the oxidation state. And I'm going to clean this one a little bit. That is the pretty nice picture. Well, that was an ion, so I have to show that. Of writing 2 redox reactions for this chemical reaction. Okay, so the oxidation reaction and the reduction reaction. We cannot just leave it the way I was showing it for the what is happening on the iodine. I have to use the entire compound in the chemical equation because I'm trying to show, and definitely it's not balanced, but this is how it is. So now we're going to move towards. So once we are done, what we have done here, we have done 2 things, right? What we have done here initially is we had to give the oxidation number to all the atoms in all the compounds in the chemical reaction. Then we'll figure out where the oxidation is happening and where the reduction is happening. Then we are all set to split the chemical reaction into oxidation reaction and reduction reaction. Make sure you're using the same species that you have. And for the oxidation, you're showing the loss of electron as a product. And in the reduction, you're using the gain of electron as a reactant. Now, then this brings us to balancing the redox reactions with the half reaction method. Okay, so this is called the half reaction method, where we split the main equation into 2 equations. One is the oxidation and one is the reduction. This is what we call half reaction method. Okay, these are called half reactions of this main equation that we were looking at. Okay, so have to have these steps handy. Okay, the steps are not going to be provided to you. Your practice is going to let you know what you are doing. So keep practicing to balance the chemical. One thing, it's balancing the redox reaction is the most challenging part for the students because they do not go stepwise. If you are following the steps, there is no way that you can make mistake. But if you just start jumping from one step to another step and you're being confused, see how stepwise I'm going from here. I have a chemical reaction. I did the oxidation states on all the molecules, ions that I have in the chemical reaction. I figured out where the oxidation is happening, where the reduction is happening. I wrote it to show loss of electron and the gain of electron. These are my two half reactions. From here, I'm going to jump on to balancing the redox reactions. How to balance redox reactions with this half reaction method, where you're splitting a chemical equation into two half reactions. The first thing that we have already accomplished is assigning the oxidation states. The second thing that we have already accomplished is we have learned that how to write down the oxidation in the reduction half reaction, and also showing how the electron is going to look like in both of them. In one is going to be the product, and one is going to be the reactant. Oxidation electron should be on the right, and the reduction electron should be on the left of the arrow, as we have already done that. So these two steps we are good. Third step is where we have to work on the half reactions separately. Okay, we have two half reactions here. We have to do the same thing on the oxidation, and then we have to do the same thing on the reduction reaction. What? We have to balance half reaction by mass first, and then we have to balance these half reactions with electrons. How do we balance half reactions by mass first? We have steps A, B, C, and D. Follow the steps. First, balance elements other than hydrogen and oxygen. Then, if there is an imbalance of so when you're done, let's say I had nitrogen and I had copper, I had zinc in my chemical reactions. I'm going to balance those first if they are imbalanced. If they are not imbalanced, then I'm fine. But if they are imbalanced, I have to balance them first. Like the same way we used to balance all the chemical equations by putting the mole coefficients in front of the molecules. Then we are going to balance oxygens by, if they're imbalanced on both sides of the chemical reaction. On oxygen, we cannot add oxygen, but we can always add water molecules. So the number of oxygen you need to balance, just add water molecules on the other side. Okay, so add water molecules where the oxygen is needed. Okay, and then as soon as you add water molecules, you are adding hydrogens also, right? So it's going to be the hydrogen imbalance in the chemical equation. So the next step is to balance those hydrogens. If the reaction is done in the acid, then you're good at this step. But if the reaction is done in base, you have to do a one step further, where you have to neutralize the added hydrogens in step C by adding the hydroxides in. I mean, you're adding a base. You cannot just directly add hydroxide ion in it. You're definitely going to add sodium hydroxide or any kind of base in it that can give you the hydroxides. Okay. After that, you're going to balance the half reactions, balance charge by adjusting the electron, and balance the electrons between half reactions, and add half reactions together, cancel everything which is similar on both sides, and sum it up and check the count. And at the end, you always check you always count the atoms on both sides. But in this chemical equations, when you're balancing them, you have to check the balance of electrons as well. On both sides, there should be equal number of electrons at the end of the balancing of chemical equation. Must solve these questions stepwise. Okay. And I'm again telling you, if you're going to lose your track, you're going to jump from like step 1 to step 4. That will be very problematic for you. So please follow the steps. So let's do example 19.2, and I have provided the solution for you guys so you can go through it all days, and you see that we are doing it stepwise. This is our chemical reaction that we are interested in. So we have to assign the oxidation state. The first step that we do, we assign the oxidation to all of them, right? So aluminum in its oxidation, in its neutral form, the oxidation state is 0. That's what we have learned. So you see the 0 oxidation state here. So what happened to aluminum from the reactant side to the product side? It went up to 3+, means loss of 3 electrons. So loss of electron means oxidation is the loss of electron. That's why oxidation is happening on aluminum. Now, reduction is definitely going to happen on the second one, because if the oxidation is happening, reduction is if something is being lost, the other species is definitely going to gain it. So what you see for the copper was initially 2+, means +2 oxidation state. From there, it's going into the 0 oxidation state. It means it has gained electron. And we know that the reduction is the gain of electron. That's exactly what you see here, +2 oxidation state to 0 oxidation state for copper. So aluminum is where oxidation is happening, and copper is where the reduction is happening. This is kind of a repetition of what we have already learned with another um, two different examples before that, right? Well, the first example was the zinc and the copper, and then we have learned it with the chlorine and the iodine example, and now we are learning it here. So it's third time actually I'm going over it. Now, step 2 is split your chemical equation into two half reaction, means oxidation reaction and reduction reaction. So now this is exactly what I'm doing. I'm separating it, okay? One thing is that I have to show my electrons as well at this step. So oxidation is because oxidation is loss of electron and the reduction is the gain of electron. And I've already told you what you're supposed to do here. So loss means 3 electrons are lost, right? Gain means plus 2 electrons here. Now it says balance each reaction, each half reaction with respect to the mass in the following order. It says balance all elements other than hydrogen and oxygen. So what do you think? Our atoms are already balanced. Okay, aluminum 1 to aluminum 1 on the other side, copper 1 copper on the other side. So elements are already balanced. So we proceed to the next step. The next step is to balance oxygen by adding water. We do not have any oxygen there. We do not have any hydrogen there. Balance each half reaction with respect to the charge by adding electron. We have already done that, right? So 3 electrons on this side and 2 electrons on that side. Because atoms are already balanced, so we had to do nothing here. Otherwise, we will have to do that. So the next step is, after step 4, we make the number of electrons in both half reactions equal by multiply one or both half reaction by a small whole number. It doesn't matter that you have to multiply each equation with the same number. You can multiply with any number or do not multiply. You multiply one equation and do not multiply the second equation. It can be anything. All you need to do is to just have them have electrons on both sides, on both reactions, have electrons in the equal numbers. Okay, that's exactly what we did. We had 3 electrons here, so we had to multiply it by 2 to make it 6. We had 2 electrons here, so we are multiplying it by 3 to make it 6. At the end, we have the similar number of electrons on both sides. And the both sides mean both half reactions. Okay, and because we are showing it, because multiplying the equation, we are multiplying the entire equation. We just cannot multiply the electrons only. We have to multiply the entire equation. And that's why we have 2 aluminum and 2 aluminum here and 3 copper and 3 copper here. Now it's time for us to add 2 half reactions together, because now the both reactions, means the reduction reaction and oxidation reactions, both are charge and mass balanced. See that they are both charge and mass balanced. Now we can add them together. Once we add them together, we have to cancel the similar stuff on opposite sides. So 6 electrons are being canceled by 6 electrons, right? And then you're going to add them together. So on the right hand side, I'm going to have this. On the left hand side, I'm going to be having this. And at the end, we have to verify that the reaction is balanced with respect to both mass and charge. Okay, so we have 2 aluminums here, we have 2 aluminums here, we have 3 coppers here, we have 3 coppers here, 6 plus charge on that side, 6 plus charge on that. That we are not writing in the chemical equation because it's on both sides, similar, okay? Now, this is what we are going to do at our own. This is an example of how we are going to proceed with it. Now, this is an example that I'm going to do for you, and then there is going to be now you practice one. Okay, that's how we will learn it.